In this video, we're going to cover how you make your own custom Python data analysis function using the IADS Post-Test Explorer client application. So I have the client application up now. I've done a search query. I'm on the calculate page. I'm on the calculate matrix, and I have a collection of results in the matrix, and I've added a calculated column of raw parameter data to the matrix. And so just as a quick refresher here, the Post-Test Explorer system is delivered with a collection of Python analysis functions. We provide a Python-based analysis library that you can go through the different categories in the expression builder here to see what is available, and that comes with the system, and you can easily add any of those functions to your matrix out of the box, so to speak. But let's say there's some sort of custom or unique analysis that you need to do that we don't provide. You can then use the built-in Python IDE that comes with the system to write your own custom analysis function. And I'll show you how to do that now. So I've already added, it helps if you've already added some raw data to the matrix, data that you want to work with as the input to your function. So I've added some accelerometer data here in this column. And so I can decide whichever cell I want to work with. I can right click on that, and I can select create new data analysis function. And what that's going to do is that's going to bring up the Python IDE that comes with IADS Post-Test Explorer. And what's going to be shown by default is you're going to get an editor window that's unsaved, and it's going to have a code template already defined for you that imports certain Python modules and decorates the function with just a standard code template that already takes care of all of the boilerplate things you need to do to get the function to be hooked into the system. In other words, you don't have to do any of this. The code template is just going to provide all of that for you. The only thing you really need to do is save the file, and you name it whatever you want. So I'll name it my demo module. Usually this will be some sort of higher level name that represents the library that you're creating. You're creating a Python library here, so you'll want to name it appropriately. So I've saved it as my demo module, and so the other thing you need to do is change the function name. So I'm going to highlight the function name, and I'm just going to call it, I don't know, my new demo function. Okay, and I'm going to save. And so now at this point, I can change any of this code to do any sort of analysis that I want. And our Python interpreter, it comes with a lot of standard data analysis packages that are popular in Python, things like NumPy, SciPy, Pandas. Those are all available to you here. It's as simple as importing them up here. This does assume that you are familiar with Python and familiar with writing Python code. So you know, it just depends on what you want to do here, but you could conceivably write any sort of analysis you want here. Now, the default code does a banded power calculation. I'm just going to leave that code in place for the purposes of this demo. So all this code is done. I'm just going to pretend like I wrote all this code myself, and now I'm happy with the results. If you, as you're writing the code, you can debug it by pressing the run or debug script buttons. And when you press that, it's automatically going to break the code on the first line of the function, and you can step through and see what your input parameters are and what the various variables you defined, how those values are changing as you write and debug the code. So the idea here is that you write your own code, you run the debugger, it feeds it that data from that cell that you right-clicked on, and you debug and troubleshoot and write your code that way. And you repeat that process over and over again until you get the result that you want. So here, I'm just going to leave all this demo code, this template code in place. Okay, I'm going to stop, I'm going to save, and I'm going to close. Now, to add that function to your calculate matrix, you go back to the expression builder, you go back to the functions tier, but instead of built-in functions, you go down to user-defined. And user-defined is where you have your entire library of custom functions that you have written. So in this example, I think I named it my demo module and my new demo func, so there it is in the list. And now I'm going to feed it one of my accelerometers as an input. I'm going to press OK. And now the values that have been calculated in this column, those have all been generated by the code that I just wrote in the IDE. So it took the code that I wrote, it fed this accelerometer data into that code, it crunched out a number, and it put it back in the matrix, and it did that for every result in the matrix that corresponds to this search result. Now, if you're looking at this column and you see that some of the values, any of the values look suspicious or incorrect, you can right click on any of them, debug, cell value. That'll bring up the Python IDE again. It will break the function on the first line of code, only it will be using a different set of inputs. It will be using whatever set of inputs that row fed the function initially. And you can look at what that input was. In this case, I called my input param. It's in the watch window. I can double click on it. I can plot it. I can view the values. I can step through the code and I can see exactly why I'm getting the value I'm getting. If that value is wrong, I can now edit the code right here in line to fix or give different results. So just as a really simple example, I'm going to bias the output here by 100 from what it was before. So I'm going to add 100 to the output. I'm going to save. I'm going to close. And now you'll see the column's recalculated and it uses my new code. So all of my outputs for this column now have an extra 100 for the value. So that's a really kind of simple demo example, but it gives you an idea of how this works. So if you don't find the analysis routine that you need in our standard package, you can always use our Python interpreter in our development environment to write your own analysis code. And that's how you write your own custom functions in the IATS Post Test Explorer system.